Hi everyone, welcome to the NLP module of the course. My name is Alec Chapman. I'm going to be giving the lectures and leading through the applied activities this week. So for these two videos, I want to start out by introducing myself and talking about what NLP is and why we're motivated to study it in clinical informatics. And then I'll give some examples and use cases, and particularly from my own research, since that's what I'm most familiar with, but I try to reference a few other researchers as well, and a few other kind of use cases that you might be interested in. And then I also want to talk through some steps for using NLP in your own research, and how you could get started with building NLP systems or using information extracted from clinical text. So I am a PhD student in the University of Utah, in the Department of Population Health Sciences with an emphasis in biostatistics. And my thesis is really going to be around how to use information extracted using NLP in statistical analysis and in kind of like a causal inference framework. And so a lot of these steps that we're going to talk about today, I've been working on for a few years. I also work as a data scientist at the University of Utah, and I earned a master's in the Department of Biomedical Informatics in Utah as well. So why are we interested in talking about natural language processing? So if you have an electronic health record, which is very common, at least here in the United States, and as I understand, is becoming more and more common in Australia, we get a lot of really good data as researchers. So you get things like diagnosis codes, medications, labs and procedures, and just all of these different vocabularies that represent clinical concepts in this structured and unambiguous way that's really nice for studying and for using in research. And so this is kind of like the surface of what we see in our data. But the problem is that in the EHR, there's all this other stuff in there that's not quite as accessible or quite as easy to use. So things like clinical notes, imaging, so like MRIs and chest x-rays, radiology reports, videos that go along with procedures. This kind of unstructured data, and I call it unstructured because it's in just kind of a format that is great to us as humans, but is not computable, doesn't make sense to machines. And there's so much of it in the HR, and we can't take advantage of it without doing some extra work. And so what is the reason for looking at that unstructured data? Why not just stick with the structured data? Well, structured data, some problems of it are that it's burdensome to clinicians. So, you don't necessarily want to go through and click 1,000 times every time you see a patient, which is what you have to do if you want to capture every single concept in a structured form. It's limited in its expression and detail. So, you can't always just say anything in a predetermined vocabulary. Although it's ICD-10 is famous for examples like this, struck by turtle initial encounter, where you can get to some really specific and try to really encode everything, but ultimately there are going to be some things that you just can't put into a structured format. And so because of this, that means that the documentation of a patient's care is often incomplete because people either don't or cannot express what they want to. And so this gives researchers and people developing clinical applications a limitation because the data is incomplete or inaccurate. So to overcome some of these challenges, you need to dig a little deeper into the data in the electronic health record and into those unstructured sources. So looking at an example like this. So this is an example of what you might see in an emergency department narrative. And so there's information here about why the patient came into the emergency department, what they're feeling, etc. And so you can break this up and see that there are some really valuable kind of concepts in here. So you see all these different clinical entities, things like signs and symptoms. So you can see that they're feeling chest pain or shortness of breath. You can see that they have certain diagnoses like pneumonia and AFib and diabetes. And you can see what medications they're on. And so all of these things are things that you might also get in structured data. And it's nice that they're in the note, but you don't necessarily need to go into the note to look at them. But there are other things that you really won't see in structured data very much. So for example, social determinants of health. Here you can see that the patient recently lost their job and housing, and so they're in kind of a tough economic situation. they're living with their mother, and so you can infer that they have some social support from their family. And there really aren't IC10 codes for some of these concepts. You can see things like temporality. So they had pneumonia a few years ago. They lost their housing just last week, so this is much more recent. You can also see kind of the way that the clinician is reasoning through their diagnoses and making plans for their treatment. So you can see what their differential diagnoses are, different things that they're considering, and then see why they order certain tests, what they're trying to rule out when they do that. And then you can see ultimately what their plans and decisions are. And you can also see things like the patient voice. So, here there's an example that they quote the patient kind of talking about their symptoms and that it feels related to a disease that they had a few years ago. And you can see their preference for that they don't feel good in hospitals and might need some help feeling comfortable. So here you're capturing not just what their diagnoses are, but you're capturing something about the patient and something that they express about themselves. And this is something that is really enhanced by the ability to put things into natural text. And so natural language processing gives us a way to extract that data that we want in those unstructured clinical narratives. And the process of using NLP is often very particular to what your research question is. So typically you'll design a system to extract particular variables, and once you do that, you can scale it to a lot of different documents. And although it's not no effort, and it's actually quite challenging, and we'll talk through some of the reasons why it's challenging, it's relatively much less effort than, say, going through all of the notes all at once. And so one of the reasons that NLP is hard is that natural language is just, really complex. I mean, ultimately, infinitely. A lot of work needs to go in to be able to transform these long strings of just characters that have inherent meaning to us humans, but you need to do a lot to get it to make sense to a machine and in something that you can compute with. And, natural language is hard enough, but clinical language has its own challenges. So for example, we have to deal a lot with negation. So we might see concepts like pneumonia in a sentence, but if you look a little closer, you see it says no evidence of pneumonia. So just because a concept shows up in the text doesn't mean that it's actually present there for the patient. Similarly, temporality. So if you see that the patient is a formerly homeless veteran, that's very different from a currently homeless veteran. And also experiencer. So especially with COVID-19, often patients might be referring to exposures that they had or the situation of their family members, but it's not them that tested positive for COVID-19, and you need to make that distinction. And there's a lot of ambiguity as well. So, for example, clinicians often have to use these kind of abbreviations, and so they might say medications include aspirin, 325 milligrams capsule, and so here CAP is referring to capsule. But in a different context of prescribe antibiotics to treat likely CAP, that's referring to community-acquired pneumonia. And so if you're looking for pneumonia, you need to recognize that this is referring to that, but this is referring to something else. And if you're looking at medications, you need to do the reverse. There's also a lot of implied meaning. So if you see a sentence like diagnosis, dementia with apathy, and let's say that you're studying apathy in this research question, this is a really nice sentence because it tells you very clearly what their diagnosis is. But you might see instead a sentence like, since his diagnosis of dementia, the patient has lost interest in doing anything. And so this is like an implied diagnosis of apathy. And you can't just look for a keyword and extract directly out. You need to kind of do some inference here. And once you develop a pattern like this, seeing that lost interest might refer to apathy, that could start to lead to some false positives because it's not always going to mean that. So for example, the patient has lost interest in bowling since she started gardening. She's not lost interest in bowling because she's feeling this general medical condition of apathy. She's just picked up a new hobby. And so your patterns that you build in one situation might lead to other problems down the road, and you need to find a way to balance those. So before going into the details of how we use NLP, or how we do NLP, I want to show some examples of what we do with NLP in clinical research. And so there are a lot of different applications that we could talk about, and I'd encourage you, if you're interested in any of these, to go through them and find more literature on them. But I'm going to focus on just the first few. So first, infectious disease surveillance. And so, the last 3 years have been, very eventful for the public health and clinical informatics community. And a really consistent theme about it has been the need for timely and accessible surveillance data. So with a new infectious disease moving quickly, we need to be able to track it in as close to real time as possible. And often this means that the data that we're using is not going to be quick or scalable enough. And so I work at the Department of Veterans Affairs, which is the largest national healthcare system in the United States, treating people who had formerly served in the U.S. military. And the VA is really unique because it's this one unified system. And so that gives us kind of a special opportunity to do things like set up a surveillance system for COVID, where we can look over a large population and track COVID-19. And so here's an example of a dashboard looking at the total cumulative cases. This is from, I think, last January 2022, so it's a little out of date. But you can see that we have counts of vaccinations, counts of cases, and because this is this big national system, it acts as a pretty good surveillance system. And so this enables kind of operations. Hospitals can make plannings, they can see what the current COVID status is like in their area. And it also enables doing research on COVID-19. So here are some papers that use data sets that are derived from that surveillance data. And you can see that there's a lot of work been done into research in COVID-19, and it really relies on this ability to identify pretty completely the COVID-19 cases in your population. And so I'm part of a team called BASIC, which is run by Dr. Makoto Jones and Dr. Vanessa Stevens here, and we've been running the surveillance system since January 2020, and it's still going now. And the information that we gather feeds into those operational and research data sources that I referenced. So why are we using NLP, or how does NLP play into this? So ideally, we'd want to be using structured lab data to do this because, a PCR, that's your gold standard for a COVID-19 diagnosis. And so hypothetically, whenever we have that, that's what we want to use. So the ideal workflow might be that a patient comes into a hospital with a cough and a fever, and they come to the VA because they're a veteran and they know they can get care here. And the provider suspects COVID-19, so they order a PCR test, and that comes back positive, and because it was done in an in-house lab, we have that structured result. And that can be logged into the EHR and go into our reporting systems. And we have, that is now included in our surveillance case counts. But unfortunately, this workflow doesn't always work. So maybe instead of going to the VA, they go to the nearest drive-through testing. And so this is totally separate from our healthcare system. And so they get a test there, and that gets sent out to some other laboratory. And that positive result now is not directly linked to our EHR or our healthcare system. So maybe instead the veteran calls their provider, tells them that they tested positive, and the provider documents this in a note. And so now that's in the VA EHR, but there's this gap now between that information and what we want to put into the report. And so to try to fill that gap, we built this COVID-19 NLP system, which we published a paper here if you're interested in learning more about it, that looks for diagnoses of COVID-19 in clinical texts so that we may add them to our overall case counts along with those structured data sources. And so the way that this works is we take a clinical document which has mentions of COVID-19 in it, and we extract those mentions, we assert some other information about it, and I'll talk more about details and give some examples of this later. And what we ultimately want is to have a document classification of whether or not they're positive or negative for COVID. And then we do a little bit of extra work like machine learning and clinical review so that we have high probability cases and we know that what we're putting in is accurate. And then that goes into our surveillance reporting system. And so as of last January, we had about 110 clinical about 110 million clinical notes processed. It's about 120 now, I believe. And these community cases, so these cases that we needed to look in the text for, account for about 40% of all cases. And so that shows that, it's a really big gap if you're not looking in the text, because a lot of information is stored there, and we would have just much less complete data and information about COVID-19 in this population if we didn't have the ability to look into those notes. And so although NLP is really complex and doing the manual review has been a lot of work, we get much better data and much more complete data. So a second example is looking at patient safety and quality of care. And so adverse patient outcomes are really important to understand how often they happen, and reports like "to err is human" really highlight the cost of diagnostic error and how frequent it is. And so we want to be able to track those, but it's challenging. And if we were able to get them, then we'd be able to give good feedback to providers. We could build sort of a learning healthcare system framework where we're improving care based on the data that we have. But first, we need to be able to identify that data. So this is a really big area, and a lot of clinical researchers work in this space. And here are 4 researchers in my home institution of the University of Utah who do a lot of work in this area. And I'm going to focus on one project that's ongoing from Dr. Barbara Jones, who is a pulmonologist and an expert in treating pneumonia. And so what Dr. Jones is interested in is looking at pneumonia and how it's really easy to miss the mark in diagnosing pneumonia. Because this diagnosis carries a lot of uncertainty. There's no gold standard, there's no PCR test for this. There are a lot of other conditions that could maybe appear to look like pneumonia. And new information comes in, kind of frequently throughout a hospitalization, which would affect what you think about the diagnosis and how likely pneumonia is. And so with all of this in mind, the diagnosis might change, and it may or may not be reflective of a diagnostic error. And so when thinking of quality, it's also a question of, some diagnoses are just difficult to capture. And so kind of an example of what might happen with the pneumonia diagnosis is this. A patient might come into the emergency room and they're admitted. The emergency doctor might think, this looks like pneumonia, and we're going to get a chest x-ray to check, but let's admit you and treat you for pneumonia. And so then a chest x-ray comes back and it shows some consolidation, some evidence of pneumonia, and they're treated for a few days, and it turns out that pneumonia really was what they had, and so it was treated correctly. But maybe instead, after they were admitted and diagnosed with pneumonia by the emergency physician, maybe the chest x-ray didn't show any evidence of pneumonia, and maybe by the time they're discharged, it turned out they had something else, like congestive heart failure. And so that means that in this initial period, they were maybe getting treatment that wasn't good for them, like antibiotics, or they were missing out on treatment for whatever diagnosis they ultimately had. And so this was a case of a false positive diagnosis of pneumonia. And conversely, maybe they didn't recognize the pneumonia initially, and it turned out to be that. And so either of these cases are diagnostic errors that we want to be able to measure and track in order to assess how much they affect patient outcomes. And so in order to do this, we need to look into the text. So at each of those time steps before, the emergency room, the chest x-ray, and the discharge, they're going to be a different note for each one. And so what this project does is it looks for diagnoses in the text, and then compares the diagnosis at the time of admission versus discharge. And this is used to construct this kind of pseudo-quality measure of diagnostic excellence. And so we developed this in the Department of Veterans Affairs, but also validated and implemented it at the University of Utah, showing that NLP can also scale across different systems. And so in addition to just identifying those false positives or false negatives, we also then want to work on a learning healthcare system. And so we use the information that we extract from those notes to give feedback to a provider. And so here's an example of a dashboard that would show a particular provider how frequently they correctly diagnosed a diagnosis of pneumonia. And would show some examples here on the right of what their notes were. And so here you thought that they had pneumonia, here are the symptoms that they had, but ultimately here's what it ended up being. And being able to pull this out of the note and provide to clinicians shows a lot of really detailed feedback. So a third area of NLP is looking at social determinants of health. And social and behavioral variables are really important to patient health, and this is becoming, much more kind of generally recognized and studied. But these concepts are really difficult to record with standardized structured data. So for example, in a note like this, you can see that there are a lot of different social determinants, social factors being discussed here. So we can see stuff about homelessness and housing instability, economic issues and job loss, transportation, family support. All of this information is really relevant to the patient's overall kind of health status. And so there are a lot of projects that looking at social determinants of health, and especially homelessness and housing instability. And here are a few examples. And one challenge with looking at homelessness is that it's not a permanent state. People can go in and out of stable housing. They can be stably housed, for a long period of time, and then have a short period of unstable housing, or vice versa. And so when thinking about trying to reduce housing instability, we need to think about, not just can we get people housed immediately and reduce the immediate problem, but do these effects on housing stability last over time? And so this is a topic that's studied by Dr. Richard Nelson, who is one of my PIs, and he is studying a program called Supportive Services for Veteran Families, or SSVF. And this is looking to evaluate the effectiveness of different types of aids and different sorts of interventions given to veterans who are experiencing housing instability. And so some examples of why structured data doesn't really cut it here is you might see a progress note like this, saying that they are here to discuss homelessness issues. She's staying in the shelter after sleeping on the street for a few nights. So with homelessness, there actually is an IC10 code to represent this. There are several related to homelessness or housing instability, so that's great. But then a few months later, we see that they're doing well in their apartment, signed a lease, and so we can see now that homelessness might be considered more of a historical condition and is not an active problem. But how do you code this in the EHR? So we had a diagnosis code for homelessness, but we don't have a diagnosis for in stable housing. And so should you just leave the code off? Should you just leave it blank and kind of, the absence of it implies that they know the absence of documentation implies an absence of the disease? Or do you code the IC10 code for homelessness because they did discuss housing issues here? These are some of the challenges when you're using structured data for these concepts. And so what I've been working on with Dr. Nelson, and what will be kind of the topic of my thesis, is using NLP to look at housing instability over time. And because this is a longitudinal condition of homelessness, we're trying to quantify how it changes over time and deal with some of the biases that occur in the text when looking at longitudinal data. So kind of roughly the way that this works is we might look over the period of January, see that they have notes saying that they're currently homeless. Then in February, they're looking for an apartment, and we're pulling out notes showing evidence of this. And initially we might see that all of their notes are classified as unstable housing, but we start to see maybe a little more evidence of some stable housing or hope for stable housing. And eventually they might get an apartment, and we see more evidence, and then ultimately, hopefully we're picking up on that they are stably housed and doing well in their new apartment. And then we can look at this over time and compare among different patient groups or different intervention groups what their housing status is and how likely it is that they are unstably housed or that they go back into a period of being unstably housed. So I'm going to pause here and I'm going to go to a different video, but next we'll go into some of the details about how we do NLP and how you can do NLP.